Welcome back you guys to yet another solution video. This time it is the latest March 2022. I'm recording this in April. This exam was written in March. It is question number 1. A curve with equation y equal to fx is such that the derivation, differentiation of that function is this. It is given that f8 is 5. Let's interpret this. f8 is 5 means y is 5 when x is 8. Right? Usually what do we write? Y equal to fx. And in place of x, they have written 8. That means x is 8. In place of y, they have written 5. So this is how we interpret this. Okay, this will help us to get the equation. So whenever we want to get an equation from first derivative, just integrate that on both sides with respect to x in this case. So it is 2, I will keep the constant out, and x to the power minus 1/3 inside, minus x to the power positive 1/3 and dx. We have to integrate them. So the integration of the derivative of f will be fx. This is what we want. Equal to 2 is a constant, remains constant, and x, the exponent, since the base is a variable, it is just simply x. We add 1 to the exponent and we divide it by exactly same exponent but complete number. Okay, now second here we'll do the same thing, 1 over 3 over, and we'll add 1 here, over 1 over 3 plus 1. Exactly same thing done here. The difference is here it was negative 1/3, it is positive 1/3 here, and then we write plus c, unknown constant. Alright, so fx equal to 2x to the power what? Minus 1/3 plus 1 will be 2/3, and we divide by 2/3 again because same thing here. So we write just 2 here, and third will be written on numerator because denominator of a denominator is numerator. In this case we can cancel this 2 and 2. Minus here it will be x to the power 1/3 plus 1 will be 4/3, and same here 4 over 3, and then plus c. Now the problem is that the equation of a function is not complete without evaluating c, and for that purpose they have given us this information. So we'll substitute this value here. Y, which is fx, is 5. So 5 equal to 3x to the power 2/3. X is how much? X is 8. So 8 to the power 2/3 minus 3 over 4, 8 to the power 4/3 plus c. So now you can see here only c is unknown, and we can evaluate others. So 5 is equal to 8 to the power 2/3 can be written as, you can use your calculator, but let me teach you how to do it mentally. 2/3 can be broken like this, 1/3 to the power 2 again, and cube root of 8, which is power 1 over 3, so it will be 2 square, which is 4. So 3 times 4 minus 3/4. By similar method, it will be 2 to the power 4, 16. 8 to the power 4/3 is 16. This 4 will cancel with 16 and plus c. So let's evaluate and complete here. So 5 equal to 12, and this is minus how much? 3 times 4, 12, minus 12 plus c. So 12 and 12 cancel out. C is 5. So our final equation becomes what they want? They want y equal to x. So y equal to, and this is the one we got here. It was 3x to the power 2/3 minus 3/4 x to the power 4/3 And now this c we got as 5 plus 5. That is the equation of the curve. Let's move on to the next question, which is number 2. A curve has an equation of this. It's quadratic, we can see that. And a straight line has an equation, this. It is a linear equation, power 1. Yeah, it is power 2. Where c is a constant. So both c's are same, okay? Find the set of values of c for which the curve and the line intersect at two distinct points. This is our requirement. Okay, so suppose this is a curve. It is a positive x square, that means it is opening up. And a line is here which is intersecting it at two places. And whatever is the y coordinate of this point, or this point for that matter, it will be same for the line as well as curve because it is a common point. That means this y and this y we can equate. So x square plus 2cx, which is the right side of the first equation, will be equal to 4x plus c, which is the right side of the second equation, y equal to y. That's what we have done. So let's collect them to one side to make it a perfect quadratic equation. Plus 2cx, this 4x comes after this, plus 4, and this c comes after that, and we are not left with anything on the right side. 4x and c both change their signs. Alright, so let's give it a look of quadratic. So x square is alone, but there are two x's, so take x out of them and write. So 2c is here and minus 4. That's the common part, x, and then we will write the remaining one, 4 minus c. Let's write them also in bracket equal to 0. Now, they have said that the two things, two curve and a line should intersect at two distinct points. That means we should have two solutions for this quadratic. And whenever we want to have two solutions of a quadratic equation, the discriminant 4v square minus 4ac should be greater than 0. And here 1 will become your a. This coefficient of x is b. And the constant part is c, and we will form an inequality of this based on discriminant. So b square, that means 2c minus 4 square, minus 4 times a is 1, c is 4 minus c, should be greater than 0, positive, right? So let's open this bracket. I'm expanding this by using this identity. A minus b whole square is a square plus b square minus 2ab. So it will be a square plus b square plus, okay, because it's a minus does not make it minus, square minus 2ab, 2c, 4. So that minus has been taken care of here. Now, if I expand this, minus 4 times 1 is minus 4, and that minus 4 times 4 will be minus 16. Minus 4 times minus c will be positive, 4c greater than 0. So this becomes 4c square here. Both are squared, okay, plus 16. And this becomes 2 times 4 is 8. 8 times 2 is 16. Minus 16c. Minus 16 plus 4c greater than 0. The constant parts are cancelling out. That is a good news. That means we'll get our answer faster without a constant. So 4c square minus how much? 16 plus 4, so minus 12. C is greater than 0. Now we have just two terms here, so let's take c, rather 4c common out of them. That is the GCF of the two. 4c taken, so we are left with 4c minus 3 greater than 0. These are the two factors of this expression. This gives us roots. Okay, whenever we have inequality, we should find out roots. This is not an equation, so we can't find solution of this. So we find root the way we find. Solution for an equation 4c is equal to 0 or c minus 3 equal to 0, right? Whenever two multiply and they are equal to 0, we get something like this, but here they are roots. This gives us c is equal to 0, that's the first root. This gives us c equal to 3, that's the second root. So now put them on a number line to get our final answer for the inequality. The smaller number on the left, which is c equal to 0. And the higher number is on the right side, which is 3. Now, our answer will be either less than 0 or between 0 and 3 or more than 3. These are the three options we have. Okay. To finalize which one is the correct answer, one way is we draw the graph, which will be a little longer. The best way is just think of a number less than 0. Say minus 1. Put that minus 1 into this inequality we are trying to solve. So if I do it, look, 4 times minus 1, minus 3. If I solve this, it becomes minus 4 times minus 4, which is positive 16. Is it greater than 0? Yes. This is our answer. What about the second one? Let's choose a number between 0 and 3. Say positive 1. So I will substitute positive 1 again here. 4 times 1, 1 minus 3. So 4 times 1 is 4. 1 minus 3 is minus 2. 4 times minus 2 is minus 8. Is this greater than 0? No. So no, this is not our answer. From 0 to 3 is not our answer. Similarly, I'll take a number more than 3 and I'm sure it will be an answer because it's a quadratic. So quadratic, we get inequality, we get either this and this as an answer or the middle one as an answer. So middle one is not there, this is there. So choose any number of your choice more than 3 and surely it is going to give you a positive number which is greater than 0. So our solutions for this particular inequality, they said find the set of values for C for which the curve and the lines intersect at two distinct points. But those sets are, first one is this one, that C is less than 0. There's no equal sign here, right? So I will not write equal sign. And second set is C is greater than 3. These are the two answers. Moving on. Find the term independent of x in each of the following expansions. So whenever we are asked a term independent of x, that means that term must not have x. And how is that possible with a part? Let's focus on a part first, okay? How is that possible with this? It's possible because one is a numerator, one is a denominator, and it's possible when both of them are like this, 1 over 6, x to the power 6. They're same exponent on both up and down and they cancel them out, right? So let's look for a combination like this where they will cancel them out. Since the total exponent should be 6, that's how we should start our answer. So 3x to the power 1, if I give us 3x to the power 1 here, that means we have to give 2 over x to the power 2 5 exponent because the sum must be 6. Okay, so is it cancelling? This is x to the power 1, this is x to the power 10. No. Let's see the second one. If we give a square to 3, what do we give to 2 over x square? We give 4. Yeah, 2 plus 4, 6. So this becomes x to the power 2, this becomes x to the power 8. Are they cancelling? No. Similarly, we can try more. Yes, this combination is working. When 3x to the power 4, we'll get x to the power 4 here. And when it is a square here, because 4 plus 2 is 6, right? So square will give us 1 over x to the power 4. They will cancel out. Yes, this is what we will zero in on now, and we know that the first one has an exponent of 4, the second one has an exponent of 2. So that's what we're going to do now. Let's start. 3x to the power 4 multiplied by 2 over x to square to the power 2, and before this we have to write NCR. N is the total exponent, we have 6. C R is this number doesn't matter which one you write. I will prefer to write this 4. Both of them will give you the same number. This is the term independent of x, and let's expand this now. Use your calculator to find it. 64, I know this is 15. Now, if I open this bracket, 3 to the power 4 will be 81. X to the power 4 will be x to the power 4 multiplied by 2 to the power 2. 2 square is 4 divided by x square square will be x to the power 4, and that was the purpose, that x to the power 4's cancel out and we'll get the term here. 15 times 4 is 60, and 81 times 60 will be 4860. That will be the term independent of x. Done. Let's focus on B part. Here also is the exactly same part left side, but we have additionally 1 minus x cube. That means we should get one term independent because of 1 term independent of x because of x cube. The one which will multiply with 1 from the first bracket is this. We are sure about this. So first term is with us. Done. The one we have to look for now is the one which will multiply with x to power 3 and cancel out. So let's do the rough work here. X cube is there, minus I'm not taking care right now. I want an x cube as a result of expansion of this. So again, same way, how can I get x cube here? So let's see, if I give 3x cube here, this one, and 2 over x square is given also cube, and exactly it is working. Can you see? This will become x cube, this will become x power 6, right? So x cube here, then x to power 6 here, and then we have x cube here. They are cancelling out. Yes, 3 will give us the right term, which will be make x cube independent of x. So we have the first thing already available with us, 4840. Second one, we'll do it now, and we decide that it will be 3x cube. That means it will be 6c3, and it will be 2 over x square cube also, and it will multiply with minus x cube from the second bracket. These are the only two possibilities where there will not be any x. Others will give you either x to the power something or a denominator x power something. So this is the second one. Let's try to simplify this. 6c3 is 20 times 3 cube is 27 times x cube times 2 cube is 8. X square cube will be x to the power 6, and minus x cube will be minus x cube. Okay, so now we can see that this cube, and this x to the power 6, they cancel out. The total is 6 on top, 6 at bottom, cancel out. This minus 1 is left here. This will make this whole thing negative. Okay, so now we have to multiply 8 and 20, which is 160, and 16 times 7 is 112, 16 times 2 is 32, plus 12, 11 rather, 43. 4,320. And now we will write this here because we already had one amount from previous part, 4,800. Okay, I made a mistake here. It will be 60. 4,860, and then minus 4,320 will be 540. Moving on, the first term of a geometric progression and the first term of an AP are both equal. So there's an AP and there's an GP. Alright, the third term of the GP is equal to the second term of AP. So AN for AP is A plus N minus 1 D, and AN for GP is AR common ratio to the power N minus 1, right? So they're saying third term of GP, third term will be A. First of all, their first terms are equal, right? And third term of GP, which is AR 3 minus 1, is equal to the second term of AP, which is A plus 2 minus 1 D. So it becomes what? A plus D equal to AR square. This is the first situation. This is the second situation. Now, fifth term of GP, which is BAR 5 minus 1, 4, will be equal to the sixth term of AP, A plus 6 minus 1, 5D. This is the third condition. With the help of these third condition, what do we have to do? Given that terms are all positive, so what it means that AP is only going up. It can't go down. If it go down somewhere, sometime it will become negative. So no, D is positive. So that's what we can interpret from this. D is positive, and of course R is also positive. R is also greater than 0, because otherwise if it is less than 0, sometimes it will be negative, sometimes it will be positive. So positive negative terms are not possible. This is the interpretation of this line. Find the sum of first 20 terms of AP in terms of A. So we don't have to find A, right? So sum of n terms of an AP is n over 2, 2A plus n minus 1 D. They're saying 20th term, right? Sum of first 20 terms, S20. So 20 over 2, 2A plus 20 minus 1 D in terms of A, and this cancels out. So we already have A here. That means D is the only one which needs to be replaced, and we have to do whole activity just to find D in terms of A. Let's simplify this one first. 10, 2A plus 19, and when we find D, we will continue here. Let's try to find D here. So we have to get rid of R, isn't it? We have to get rid of R so that our equations are only in terms of A and D, and then we can find D. All right. So first, let's call it number 1, number 2, and number 3. So if we divide number 2 by number 1, what situation will get? Number 2, A plus D divided by A. Left divided by left. Equal to right AR square divided by A. See, A and A got cancelled out. R square is A plus D over A. Alright, this is equation number 4. Now to get one more situation, we can divide 3 by 2. So A plus 5D, left side, divided by the left side A plus D, equal to A AR to the power 4 divided by AR square. So again A cancels out here, and R square also cancels out, and it will be left with only 2. So this gives us R square equal to A plus 5D over A plus D. And yeah, we have this equation number 5, and if you see, it is R square here and it is also R square here. So both are same. That means we can eliminate R square by this, by equating the left side equal to left side, because both are equal to R square, right? So that is going to give us some solution. Okay, A plus D over A is equal to A plus 5d over a plus d. So left side equal to left side. Alright, cross multiply, so it will become a plus d square. Isn't it? They are exactly same. Equal to, this multiplies here, a multiplied by a plus 5d. We're getting squares here, but hopefully they'll get cancelled out. If I expand this, a plus b whole square is what? A square plus d square plus 2ad equal to a times a is a square. Yes, square is gone. 8 5ad. Right? And we have to use it. Let's continue here. So a square on both sides we can cancel out by subtracting a square from both sides. So don't even look at this. D square is left here, and 2ad I'll bring it to 5ad so that we get 3ad. Yeah. So d square equal to 3ad. Let's divide both sides by d to get rid of one of the d's. So this d and this d cancel. This d and one of the d's are cancelled. So d is equal to 3a. That is what we got, d in terms of a. We had to eliminate r square. We eliminated here. We had to eliminate d. Now we are going to eliminate. In place of this d, we will write 3a. So S20 is 10 times 2a plus 19 times 3a. So it becomes 10, 2a plus 19 times 3 is 57, 57a, 59a. And S20 finally comes out to be 590a. S20 is in terms of a now. Done. Let's see what is next. Number 5. Express this quadratic in terms of this. There are many ways of this, and in my previous videos also I've shown that one method which fascinates me and which is easier to do is this one. 2x minus a square plus b. This is what they've given. Expand this. So main question will be done here. I will just expand this here. 2 times, I will expand this, a minus b whole square. I have expanded this in previous part of this video. So x square, which is a square, basically a square of that identity, okay, not this a square, plus a square minus 2ax is the expansion of this one. Bracket is finished, so I don't have to write any bracket. B was extra. So let's expand further. 2x square, 2a square. 2a square is a constant, so I'll write it later. 2 times minus 2x is minus 4ax, and 2 times b is 2b. So this becomes 2x square, coefficient of x square is 2, coefficient of x is 4a, and the constant part is 2b plus 2a square, right? Let's compare this with this one. 2x square minus 8x plus 14. Can you see 2x square and 2x square are same? Don't look at that. Minus 8x will be compared with the coefficient of minus 4ax. Let's write x also, and then we can cancel out x. Minus 4a is equal to minus 8. So divide both sides by minus 4 now, so that we get the value of a. And that is 2. A is 2. So our format was this. 2x minus a. A is, we got 2 now. Square. Now only thing left is to find the value of b. So we can find by comparing the constant now. The constant is 14 here. Constant are 2b plus 2a square here. So 2b plus 2a square is positive 14. A we just found out how much? 2. So 2b plus 2 square is 4. 4 times 2 is 8. After substituting a equal to 2, 14. 2b equal to 14 minus 8. If we subtract 8 from both sides, 14 minus 8 is 6. And that gives us b equal to 3. Voila, we've done this. We've converted this quadratic into this format. So this is the one. The function f and g are these, and if you look at g, it is exactly the same which is in part A. 2x squared minus 8x plus 14, right? They're saying describe fully a sequence of transformations that maps the graph of y equal to fx, this one, x squared, a simple quadratic parent function, onto the graph of y equal to gx, this one, making clear the order in which the transformations are applied. All right. So y equal to fx becomes y equal to, I'm not writing this gx, rather I will write the transformed way we converted this one. 2x minus 2 square plus 3. Now, this is not a ideal transformed part, so let's multiply 2 with all of its contents, which are these two. It will be equal to 2 times x minus 2 whole square plus 6. Right? Now, this was already equal to x square. Now, the square part is only here or only here. It has a number in front and something is adding here. Right? And there is something subtracting inside. So, the order. If you know in your childhood, you might have learned a rule called bed mass. Right? Multiplication and division takes place before addition and subtraction. What is multiplying and what is exponent? Exponent was already there in the original one. X square was already there. So this exponent will not be counted. In transformations, we follow the same rule here, that multiplication, 2 is multiplying with this, right? And x, this one, x square was the original function y. So that means there will be an effect on y because of this 2, and that is the first step. There is an expansion or stretch in y direction by a factor of 2. Right? Then addition. We'll look at this addition, plus 6. Okay? We could have looked at the subtraction also because they are independent. This is in x direction, this is in y direction. So whichever we write first is not important, but because we said addition first, so let's take the 6th one first. So this 6 is also adding to the what it means is that the particular graph, the x value which was starting at a specific point starts 2 units late, delayed by 2 units. So if it is say 3, it will start at 5 now. It goes to the right by 2 units. Every point goes to the right by 2 units. So that's what we will write. Horizontal translation of every point in x direction. How many? 2 units to the right, not to the left. Minus does not mean left. Minus in a transformation means moving right. In case you want to combine these two, you can write, in place of these two, you can write translation by, it is 6 units. to up, right? So it will be 6 units in y direction, and there are 2 units to the right, so it will be 2, 6. That's what it will be. The circle with equation this given here and the straight line with equation this one are shown in the diagram. The line intersects the circle at A and B. Okay. At the center of the circle is C. Alright, this is, it's not connected with anything. Find by calculations the coordinates of A and B. Since the points A and B both lie on the circle, that means they will satisfy the equation of the circle, which is this, right? So let's plug in 3x minus 20 in place of this y in the equation of the circle, because these 2 points are on the line as well, and that will give us a quadratic equation which will give us 2 points. All right, so let's do it here. Let's start here. X plus 1 square plus, in place of y minus 2 I will write 3x minus 20. 3x minus 20 minus 2 square equal to 85. I hope you understand. In place of y, 3x minus 20. So it becomes x plus 1 square plus 3x minus 22 square equal to 85. And let's expand these again, just like the ones we have done in previous questions in this exam. A square plus b square plus 2ab. Here x a square plus b square, square of 22 is 484. Minus, in this case, 2 times 3, 6 times 22 is 132x equal to 85. And let's bring 85 to the left side and simplify this here. So it will be x square plus 9x square will be 10x square. Then we have 2x and minus 32x minus 130. And then we have 1 plus 484. 485 minus 85 will be 400 equal to 0. Since all of them have 0, let's divide all of them by 10 so it becomes easier for us. So it cancels, cancels, cancels. X square minus 13x, it was x, right? Yeah, 13x plus 40 equal to 0, and we can now use factorization or quadratic formula or your calculator to do this, and let me do it hurriedly my factoring way. So it gives me x minus 8 minus 5x minus 8. So x minus 5, x minus 8 equal to 0. The two x coordinates, because of this we get x coordinate equal to 5. Because of this we got x equal to 8. So the x coordinate of b is, it is before a, right? So 5 will be here and a will have 8. What about y? It will not be a wise idea to use this to find y. It will be good because they are on line as well. Use line formula. So y equal to 3, and let's put this 5 first for b, minus 20. So 15 minus 20 is minus 5. So the y coordinate of b is minus 5. And that makes sense, right? It is below x-axis, minus 5. What about the y coordinate of this second one? Y equal to 3 times 8 minus 20, which is 24 minus 20. Positive 4. Perfect. Right? Question was, find by calculation the coordinates of A and B. So coordinates of A are 8, 4 and B 5 minus 5. There is another part of this. Find an equation of the circle which has its center at C, okay, and for which the line with equation 3x minus 20, the same line, okay, is tangent. And let's try to draw the new circle within this circle with center C. Okay, here it is, and this should be tangent to this circle, yeah, with center C. Almost. Okay, so now if I draw a line from center to the point where the tangent is meeting and cross it further, yeah, it is a line from center towards the circumference of the circle. There is a fact that a line from center and touching to the circumference where the tangent is meeting the circle, it always forms a 90-degree angle at that point with the tangent. Okay, and also this line from center to the circumference divides the chord into two equal parts if it is 90-degree to the chord. So AB is a tangent to the small circle, but it is a chord of the bigger circle, and that's why let's call this point M. So AM will be equal to MB, right? That means M is the midpoint of AB. We know the coordinates of A and B now. What are they? Let's see. They were 8, 4 and 5 minus 5. So 8, 4 and 5 minus 5. So let's find the coordinates of M, the midpoint. Okay, it will be 8 plus 5 divided by 2, x1 plus x2 divided by 2, and then we'll have 4 plus minus 5 divided by 2, which comes out to be 13 divided by 2, 6.5, and minus 1, so negative 5, right, divided by 2, negative 0.5. That is the coordinate of M. Now, we want the equation of the smaller circle, right? Since we know the coordinates now, 6.5 and minus 0.5, and the center is already known to us because of this equation, the x coordinate will be minus 1. We always have negative of what is there in the brackets here, minus 1 and 2. Negative of negative 2 will become positive 2. This is the center. And now 85 was the radius of the bigger circle. We can't use this one. Okay, so we will write, we'll find the radius first. So it will be 6.5 minus minus 1. So radius of smaller circle will be square root 6.5 minus minus 1 square plus, I'm using the distance formula, minus 0.5 minus 2 square. So it will be how much? 7.5? Yeah, 7.5 square, which will be 56.25 plus negative 2.5 square, which will be 6.25, and that too positive because of the square. Alright, so if we add these two, we get square root of 62.5. This is the radius. Now we will use the exactly same equation because the center is same. The equation of the new circle, let's write equation of smaller circle will be x plus 1 square plus y minus 2 square will be equal to, the radius is not 85 anymore, radius will be, radius square rather, will be this 62.5. This is the square of the radius, and this is the equation of the smaller circle. Question 7. A part, show that the left hand side of this identity is equal to the right hand side. So since left hand side is more complicated, let's focus on this left hand side, and we will prove that this is equal to right hand side. So the strategy to make two different terms with a negative in between one term and they are rational, just try to merge them by making their denominators same. Just like this. If you have half minus 3/4, you do what? You make the denominator same so that you can subtract them easily. That's what I'm going to do here. So to make them same, let me write the first one first. 2 cos theta over cos theta minus 2 sin theta. This is the first term. Now, if I multiply this denominator by the other denominator, so let me put a bracket here and multiply by cos theta plus 2 sin theta, which is actually conjugate of this. This is negative, this is positive, this is the only difference between them. So I multiply denominator, I have to multiply numerator also because I'm effectively multiplying by 1. So multiplied up and down by the denominator of the other term. Minus, let's write the other one. Sin theta minus 2 cos theta. Here I want to mention that this minus applies to both of them. That means if I somehow change this minus to positive, this negative will be affected by this negative as well. Okay, just keep that in mind for future. Maybe that will be used. So this is the second term. Now I am multiplying it by the denominator of the other one. So it will be cos theta minus 2 sin theta, and here also cos theta minus 2 sin theta. Okay, let's open the denominator first, and it is again the same identity we used in one of the earlier questions. A minus b, a plus b. Whenever we have such a situation, they are multiplying. It is a square minus b square. In this case, it is 2 sin theta. A square minus b square, that's simple. This is the denominator of both of them now. And now we will write the numerators of both of them together because they have same denominator. So 1 by 1 sin theta times cos theta. Very patiently do this. Most of them will get cancelled out. I'm sure about this because we have just 4 here on the right hand side. If you see, that means all of them will get cancelled out. So let's see 1 by 1. So sin theta times 2 sin theta will be 2 sin square theta. Plus 2 cos theta times cos theta will be plus 2 cos square theta. Plus 2 cos theta times 2 sin theta is 4 sin theta cos theta. Minus, this minus, okay? We'll put everything in bracket because this minus is going to change all of them. Sin theta times cos theta is sin theta cos theta. Sin theta times 2 minus 2 sin theta, it will be minus 2 sin square theta. Minus 2 cos theta times cos theta will be minus 2 cos square theta. And finally, minus 2 cos theta times minus 2 sin theta will be plus, let me write here, 4 sin theta cos theta. Now, if you look at this, this is sin theta cos theta, this minus will make this one sin theta cos theta minus. They're exactly same, they cancel out. 4 sin theta cos theta is positive here, and because of this minus, this positive will also become negative, and they're exactly same, they also cancel out. So what are we left with here? 2 sin square theta plus 2 cos square theta. Let's write them here. 2 sin square theta plus cos square theta. I took 2 common out of the both, these two. And here, because of this minus, and this minus both will be positive again. So plus and take 2 common out of them also. It will again be sin square theta plus cos square theta. Simplified. Divided by cos square theta. Okay, let's see the target. What is the target? Target is cos square theta. That means sin square theta should go. This sin square theta should go. So it will be cos square theta will remain cos square theta minus, it will become 4 sin square theta. Yes? If I look at this, 4 sin square theta. And we know that sin square theta is equal to 1 minus cos square theta. This is I'm going to write here. 1 minus cos square theta because I don't want sine square theta. Let me summarize again. Because of this square, this 2 square is 4. Because of this square, sine theta will be sine square theta, and sine square theta is 1 minus cos square theta. That's why I wrote it here. Alright. Sine square theta plus cos square theta is 1. So just 2 is left. Plus this sine square theta plus cos square theta is also 1. 2. Cos square theta minus 4 and plus. Because of this minus and this minus, it will be plus 4 cos square theta. And finally, 2 plus 2 is 4. Cos square theta plus 4 cos square theta will be 5 cos square theta minus 4, and hopefully this is the right hand side. Yes. If you want to know the strategies of solving quadratic, if you want to know tricks and tips to prove trigonometric identities, I will put up a link of one of the videos on my channel so that you understand how we prove these kind of identities. Hopefully that will help you. Okay, let's go to the B part. Hence, solve the equation this equal to 5. I hope there is no difference. Sine theta cos 2 theta. Okay, exactly same. So in place of this left hand side, we will write the proven right hand side, and that will become our new equation. So 4 over 5 cos square theta minus 4 is equal to 5. This is what our equation, this equation becomes, because this has been replaced by its equivalent. Alright, so we'll do the cross multiplication first. 4 equal to 25 cos square theta minus 20. So this minus 20 I can bring with this 4. So 20 plus 4 equal to 25 cos square theta. Okay, and our domain is 0 to 180. So that will be easy. Okay, 24 equal to 25 cos square theta. Divide both sides by 25 to get rid of 25 from the right side. Cos square theta equal to 24 over 25. We square root both sides to get rid of the square here. We'll square root here, but we'll write plus and minus both. Why? Whenever we square root, we have to write plus and minus both, and they have not specified that we can't have a negative value for cos theta. And because square of a negative number is also positive 24 over 25, so we have to write both positive and negative here. Alright, since we need to look for the answers from 0 to 180, let's look at our quadrant. This is 0, this is 180. Cos is positive here, cos is negative here. So both of them will take into account. First, let's put cos inverse square root 24 over 25 in a calculator and try to find the acute angles in these respective quadrants, which will give us the answer. By the time I do this, I would request you to subscribe to my channel. Please like this video and share with your friends so that they also get benefited, and I'm motivated to make even more videos like this for you guys. Okay, what I got was 11.5369. So I will take just 3 second even figures 11.5. So this acute angle is 11.5. This acute angle is also 11.5. So the first answer for us will be theta 1, which is 11.5 itself, because we are starting from 0. We reach to this line. 11.5 is your first answer. Second answer will be, we'll move on to this yellow line again, which is 11.5 less than 180 degrees, and which will be 168.5 degrees. These two are the two answers for this equation. Let's move on to the next, which is also based on a circle. The diagram shows the circle with equation this. The chord AB, okay, is given. The circle intersects with positive y-axis. All right, that means the x coordinate for this is 0. That's what it means when it meets axis. And parallel to x-axis is AB, this one, right? Find by calculation the coordinates of A and B. This is the equation. Basically, they're asking us to find the y-intercept of the circle. And we can see we have two y-intercepts, not one. So obviously one of them is positive, one of them is negative. So positive one we will give it to A point. So let's put x equal to 0 in this one. So it will be 0 minus 2 square plus y square equal to 8. So minus 2 square is positive 4 equal to 8. So let's bring this 4 to the right side. Y square equal to 8 minus 4. Y square equal to 4. Square root both sides, just like previous question. We will write plus and minus both 2. That means the y coordinate of this one is positive 2. Y coordinate here is negative 2, which nobody is asking, but that is what we'll know. Okay, now we have got the coordinates of A. Because the y level of both A and B is same, that means the y coordinate of this will be 2. We have to find just the x coordinate. Any line parallel to x-axis has same y coordinates. So 2 is the y coordinate. So what will we do? We'll now substitute 2 into the main equation here and we'll find two x's again. One of them obviously will be 0. Second one will be our answer. So let's do it. X minus 2 square plus y is 2 for us now equal to 8. X minus 2 square equal to 8, and this 2 square is 4, goes to the other side again. X minus 2 square is equal to 4, square root again both sides, so that this square roots, and we write plus minus here. X minus 2 is equal to plus 2, and x minus 2 is also minus 2. So let's see what it gives us. X equal to 2 plus 2 equal to 4. This x coordinate is 4. Obviously this is the one, 4. The other one will be x equal to minus 2 plus 2, which is 0, and we already knew this 0. So this is of no use to us, but the other one is. We got the coordinates of A and B both. Alright, there is a B part also. Find the volume of the revolution when the shaded segment, this one, is bound by the circle, okay, this circle, and the chord is rotated through 360 degrees about x-axis. So whenever we want to find the volume, let's see how this volume will look like. So if we rotate this shaded part, it will become something like a picture. Like this. But because of this white part, it will be hollow. There will be nothing inside this volume. So what will we do? We'll find the volume by rotating this whole area under AB part of the circle, and then we will subtract the cylinder which is inside. Let's find the volume of that cylinder which we have to remove first, this hollow part. It will be, what is the volume of a cylinder? Volume of a cylinder is pi r square h. This volume I'm talking about, this cylinder from here, this cylinder. Alright, so this cylinder pi, let me undo this to make it clean. So pi r square, r is OA, this is radius, OA is 2, let's write it 2 square, pi r square, h is AB, this height is h is 4, so 4 times 4, 16 pi. 16 pi is the volume of this inner cylinder inside here, which we'll have to remove later. So once we find our volume, we'll subtract 16 pi from it. How do we find the volume of this whole drum? It will be from 0, yeah, till this is 4, right? From 0 to 4, pi y square with respect to x. This will give us the volume if we rotate this whole AB arc 360 degrees, and this drum will be formed. So it will be pi from 0 to 4 y square. We'll have to rearrange this one. Y square will be 8 minus x minus 2 square. So it will be 8 minus x minus 2 whole square dx. This volume we have to find out. So let's integrate this. Pi will be pi, keep it out. Integration of 8x. Integration of, it's a linear with a exponent on top, which is a very good situation for us. Just treat it like a normal variable and add 1 to the exponent, divide by the same exponent, and further we have divide by the differentiation of the contents of the bracket. X minus 2 differentiation is just 1, so it doesn't make any difference, plus c from 0 to 4. And let's substitute the values now. 4 and 0. First 4. 8 times 4 minus 4 minus 2 to the power cube. 2 plus 1 cube divided by 3 plus c minus 8 times 0 minus 4 minus 0 cube. No, it will be 0 minus 2. 0, x is being replaced, right? So 0 minus 2 square over 3 plus c. C and C should be cancelled. That's the first thing you should do. And we are left with what? Pi 8 times 4, 32. 4 minus 2 is 2. 2 cube is 8 over 3. Minus 8 times 0 is 0. We will not look at this. So we have 3 minuses here. This minus will make it positive. But 0 minus 2 cube will be minus 8 over 3. So it will again become negative 8 over 3. 3 negatives, negative here. So how much that becomes? Doesn't have 3. So let's multiply this also by 3. So it becomes pi 96 minus 8 and 8, 16 over 3, which is 80 over 3 pi. Now this is the volume of the whole drum. Now we have to remove the cylinder we found initially from it. So we can write here finally the volume of the hollow shape formed by rotating shaded area is equal to 80 over 3 pi minus 16 pi. So 48, 32. 32 over 3 pi. This is the volume. You can write units cube. Question 9. Functions f, g, and h are defined as follows. Solve the equation fx equal to 0. So g and h are not involved in this question. So let's focus on only fx. Let me copy what is fx. Fx is equal to x minus 4, x to the power half can be written as square root x plus 1. And it is equal to 0, and that's what we have to solve. So the equation becomes x minus 4 square root x plus 1 equal to 0. With the square root, it will become difficult to solve this. So let's do what? Square root x is equal to, let's say, t. So what will be x equal to? Let's square this. So this will be squared. So x becomes equal to t square. So square root x is t, x is t square. So what does this equation become now? X is t square minus square root x is t plus 1 equal to 0. And now it becomes a simple quadratic equation that we can solve. I don't see any chance of factoring this and getting an answer, so it will be good to use quadratic formula, which is this. and that will be equal to t. So for us, 1 is A, minus 4 is B, and 1 again is C. Let's substitute here in quadratic formula. So minus 4 plus minus square root B square, minus 4 square again, 4 times 1 and 1 divided by 2A. Alright, so it becomes positive 4 plus minus square root 16 minus 4, right? 4 times 1 times 1, okay, 2. So we get 4 plus minus, that is t again, square root 12 over 2. Square root 12 can be written as square root 4 times square root 3, right? Which becomes square root 4 is 2 and square root 3 is square root 3. So 4 plus minus square root 12 becomes 2 square root 3, isn't it? Square root 4 is 2 and remaining is square root 3 divided by 2. Now we have even numbers, all three of them, with a plus here. We cannot cancel these two because there is a plus or minus in between. But what we can do is that we can cancel this with each one of the above terms if they have a plus or minus inside. So this 2 is cancelled, this will be remaining as 2. So we'll get finally t equal to 2 plus minus square root 3. And t was not given in the equation. We created t, so we'll go back to square root x equal to 2 plus square root 3, or square root x equal to 2 minus square root 3. And whenever this is solved, they mean find the value of x, not square root x, because x is the variable here, right? So to find the value of x, again we will square it and square this side as well. Let's do them separate. So if I square here, this square root gets cancelled. X is equal to, and again in this exam we have used the many a times, a plus b whole square. It is equal to a square plus b square plus 2ab. Similarly here, x will be equal to a square plus b square minus 2 times ab. So the difference here is plus and minus again. So here it becomes 4 plus this square root and square cancel, 3 plus 4 square root 3. That is 7 plus 4 square root 3. Here we get 7 minus 4 square root 3. And if we want to combine the both, we'll get 7 plus and minus 4 square root 3. This is the solution of fx equal to 0. The next part is this. Given that fx is equal to ghx, find the values of m and n, ghx. So this is ghx. Let's find ghx here only so that we can solve it easily. Alright, ghx. Ghx also means g of h of x. Okay, so what is h of x? This one, it is square root x minus 2. This is how we can write it. So it becomes g square root x minus 2. It means wherever we have x in g, this is an x, that this is the only x we have, replace it by square root x minus 2. So let's do it. So it becomes m, and in place of x we will write this now, square root x minus 2 square and plus n, right? So if I use bed math, so I have to open this square exponential first. So m will remain m, and it will be again a minus b whole square that we used previously. So a square, which is complete x, square root x square will be complete x, plus b square, square of 2, 4, minus 2 times a times b. So what does that become? mx, m multiplied by x plus 4m, okay, minus 4 square root, okay, minus 4m square root x. You can pause the video and see how I got this. This m multiplied with whole of the bracket, and then this n was untouched. We write n after this. So this is what I'm going to use there as GHX. So what was fx? It was this x minus 4 square root x plus 1. Now these two will be used to solve. X minus 4 square root x plus 1. This was fx. GHX, we just got it equal to this. Alright. So now you can see that this x is matching with this term, right? There's no other x here. That means 1x, which is this, is equal to mx on the right side. No other way they can be equated. And that means x and x, if we divide both sides by x, they get cancelled out, right? So m comes out to be 1. Straight away we got the value of m equal to 1. Now let's compare the square root x part. Minus 4m square root x, which is this here, will be equal to minus 4 square root x. And if we divide both sides by minus 4 square root x, this cancels with this, they cancel. M equal to 1 again. So there was no use by focusing on this. So let's go to the third part, which may give us an answer. Third one is a constant 1, which will be equal to the constants here. 4m is a constant, n is a constant. So 4m plus n will be equal to constant. Constant equal to constant. And this may give us the value of n. So 1 equal to 4, and m is 1 in previous cases, plus n. So 1 minus 4 times 1 is 4, and when it comes to left, minus 4 equal to n equal to minus 3. That's the value of n. Let's move on to the next one, which is question number 10. These are the two circles given, a triangle in between. The explanation is here. Please pause the video, read this, and then they are asking to find the perimeter of the shaded region. We can see the shaded region. So perimeter of the shaded region will be the line segment DE, this one, arc EC plus arc DC. This is perimeter. So somehow if I find these three things, we'll get the perimeter. Let's focus on the triangle first, this triangle. If this is 5, this is 8, total 13, and this side is also 5 centimeter because it is the radius of the same circle which has the radius of 5 centimeter. So we can find the third side by Pythagorean theorem because there is a right angle triangle here. So according to the Pythagorean theorem, AD, which is the radius square, plus DB will be equal to AB square, right, by Pythagorean theorem. Alright, so let's substitute the values. AD is 5 square plus DB, we don't know it, let's write it as DB only. AB square is 5 plus 8, 13 square. So DB square will be equal to 13 square minus 5 square, which is 169 minus 25, 144. So square root this and square root this, square and square root cancel out. DB will be equal to plus or minus 12, correct? But I'm ignoring minus because the length cannot be a negative one. So DB is 12. EB is 8 centimeter because it is the radius of this bigger circle. So that means DE will be 4 centimeter, then only it becomes 12. 4 plus 8, 12. So we have the sides here. DE is known to us now, it is 4 centimeters, right? Next, we have to find the arcs. For finding arc, we need to know these angles. This angle, if I know, I can find this arc because the formula for arc is r multiplied by theta. And this theta should be in radians only. Just keep in mind. R we know, 5 centimeter. Theta is what we can find out. So, if I look at this right angle triangle again, and let's call this as angle alpha and this as angle beta. So if I focus on angle alpha, can I say that sine alpha is opposite? Opposite to this alpha is this dB, which is 12 centimeters, divided by hypotenuse, which is AB, 13. So alpha is sine inverse 12 over 13. Right? And now if I use this formula, I can easily find arc DC, which is here we want this, equal to r theta. R radius is 5. Theta we just found out, sine inverse 12 over 13. This is the angle, and there's no need to evaluate this. We'll do it together later. Let's keep it here only. Second arc is EC, which is this one. For that, we need to know this angle beta. So, sine beta in this case. I'm using sine, you can use cos or tan. Whenever we have three sides available of a right angle triangle, we have the luxury of using cos and tan as well. But I'm using sine. Doesn't matter, everyone will give you the same answer. So, beta, what is opposite? 5 centimeter is opposite over hypotenuse 13. That gives us beta equal to sine inverse 5 over 13. So our second arc EC, which we needed, is 8 is the radius this time. 8 is the radius of this angle beta, this sector. EC will be 8 times sine inverse 5 over 13. And now let me evaluate both of them with my calculator and put it here, and we'll get our perimeter. By the time I do this, I request you to subscribe to my channel, like this video, share with your friends so that they also get benefited, and I'm motivated to make such videos for you in future too. Thank you very much. When I use my calculator, I got this as 5.88 centimeters. This one 3.158 centimeters. And when I add all three of them, let me write EC is 3.158 plus 5.88. So all of them give me 13.03 centimeters. And if we round out to 3 significant figures, it becomes 13.0 centimeters. This is the perimeter. Let's talk about the area. Obviously, next time they ask the area of the shaded region. All right. So let me plan the area of the shaded region first, and then I will do it. Okay. This is the shaded region. If I find the area of this triangle, right angle triangle ADB, right? It's a right angle triangle. What is the base of this? Because the area of a triangle is half base times height, correct? And base is 5. Because this side is 90 degree on it. Any side that is side or any line that is 90 degree to the base and connecting with the vertex, opposite vertex, becomes the height. So the base is 5 centimeter, height is 12. We get the area of the triangle, correct? Now, from this triangle, if I remove this white part, this sector and this sector, find their areas separately, I will get the area of the shaded region, which will be left out of the triangle, right? I hope you understand. Let me make it cleaner and write somewhere else. Okay, so let's go to the lower part and do it there. So we have the triangle whose angle is 90 degree. Here we have 12 centimeters. This is 13 centimeters. This is 5 centimeters. Then we have a sector that we have to remove, whose radius is 5 centimeter. Then we have another sector which we have to remove, and its radius is 8 centimeter. This angle is sine inverse 12 over 13. This angle here is sine inverse 5 over 13. So our area will be, area of the shaded region will be area of the triangle minus area of the sector 1. Let's call it sector 1. This is sector 2. Minus area of sector 2. Okay? So area of the triangle first. Area of the triangle is half base. Base is how much? 5. This is counted as base. What is height? 12. Minus area of any sector is half theta r square. Theta is in, again, radians. I am insisting about it being in radians because if you use degrees, your answer will be totally different. So never use degrees, only radians. Half theta we know now, which is sine inverse 12 over 13. I'm not using its actual value because let it leave it to the calculator. Okay, r square, the radius of this, which has the angle sine inverse 12 over 13, is 5. So 5 square is 25 multiplied, and then minus another one is theta is sine inverse 5 over 13 multiplied by 8 square. If you can see here, the radius here is 8 centimeter. Alright, so 2 cancels with 12, 6. 6 times 5 is 30. Minus half sine inverse 12 over 13 multiplied by 25 will give you 14.7. And when I put this half sine inverse 5 over 13 times 64, I get 12.6, almost. It is not exact. There are more digits after this, but I need 3 significant figures, so this is enough for me. And the answer comes out to be 20 minus, so not 30 minus 27.3, which is equal to 2.7 centimeter square. This is the area of the shaded region, which was the remaining area of the triangle. Moving on to the next question, which is number 11. It is given that a curve has this equation where k is a constant. Okay, find in terms of k the values of x at which there is a stationary point. Okay, so we know that for stationary point, the differentiation of the function should be equal to 0 because this is the gradient of the tangent, and at stationary point when the curve is changing its direction, the tangent is a horizontal line whose gradient is 0. That's why we write dy over dx equal to 0. So let's differentiate this first. So dy over dx, I'm doing this straight away, differentiation of this one. K is a constant, we won't touch it. Okay, now we will differentiate this one. For differentiating, it's a linear function inside, so this minus 1 comes in front, and the exponent of 3x minus k goes down by 1. Minus 1 was already there, it goes down by even 1 more, right? And then since it's a function in itself inside the bracket, we differentiate what is inside and multiply with that differentiation. What is differentiation of 3x? 3. What is differentiation of k? It's a constant. So differentiation of k is 0. So no need to write it. Just the whole thing, differentiation is 3. Next we have 3x. So the differentiation of 3x is just 3. So let's multiply this 3k and minus 1. It becomes minus 3k. And 3x minus k to the power minus 2 plus 3. And we have to make it equal to 0 because at stationary point, dy over dx is equal to 0. So This is what we'll do. Since this is 0, we can, oh, it's a constant. So we can take it to the other side because factoring will not help because it's a constant. So 3k, and let's divide it also. 3x minus k square. Because it's a negative exponent, I made positive by making the denominator. Equal to minus 3. This 3 taken to the right side. Okay, so now we can divide both sides by minus 3 to get rid of minus 3's. Okay, cancel, cancel, cancel. So we are left with k over 3x minus k square equal to 1. Okay, not 0. Many people think if it is cancelled, it becomes 0. It becomes 0 when we cancel by subtracting. Okay, when we are dividing, it is left with 1. Okay, so let's do cross multiply. It comes and multiplies with 1. So k is equal to 3x minus k square. Our purpose is to find the value of x. That means it has to be isolated, made the subject. For that we need to get rid of this square. We'll square root both sides. This cancels here, but this does not cancel. But when we square root some constant, it has to be positive and negative both. And we can have positive and negative both values in case of a function. So we'll write both 3x minus k. Now x is our focus. Let's bring this k to the left side. It becomes positive k plus square root k. Okay, and anything? No, 3x. And now divide both sides by 3 so that this 3 cancels out and x finally comes out to be k plus minus square root k over 3. This is the value of x at a stationary point in terms of k. Moving on, the function f has a stationary value at x equal to a and is defined by this. And if we compare it with the previous one, 4 3x minus 4 plus 3x, I think it is exactly same. In place of k, yes, in place of k they have written 4. All right, so this same equation but k is equal to 4. That means we can write this equation. X is equal to, in place of k I will write 4 because it's a stationary point. This thing has a stationary point at x equal to a, and that x will be when we'll substitute k with 4. So let me try to do this. So 4 plus square root 4 is 2 over 3, which is 6 over 3 or 2. This is the first value of x. Second will be 4 minus 2 over 3, which is 2 over 3. But they're saying it is x is greater than 3 over 2. Yeah, it is greater than 1.5. 2 over 3 is not greater than 1.5. So this one is inadmissible. We will not look at this one. This is the answer. X is equal to 2. Find the value of a, we found it, and determine the nature of the stationary value. To find the nature of the stationary value, we differentiate it once more. What was the differentiation? Let me see. This was the differentiation, yeah? This was the differentiation. Let me copy this one first. Here it is. So I have to differentiate this once more. Second derivative I will find out. So d square y over dx square. Second derivative of this will be minus 3k is again a constant. This time k is 4, okay? So minus 12. Because minus 3 times 4 will be minus 12. And this differentiation of 3 will be 0. So we will not even look at this. So only thing we have to differentiate more is this one. So minus 2 comes in front, just like previous time. 3x minus 4. In place of k, I'm writing 4 now. Minus 2, it goes down by 1 further. And we multiply by the differentiation of the content, which is 3. So it comes out to minus 24, positive 24 times 3 is 72. Divide 3x minus 4 to the power minus 3. Now we know our value. When x is equal to 2, what will this be? Second derivative, d square y over dx square equal to, yeah, So let's complete here. 6 minus 4 is 2, 2 to the power minus 3. 72 divided by, rather let's multiply by 2, 2 to the power minus 3. So 72 divided by 8 is 9. Why divided by 8? Because we have to make it positive. You can straight away put this in a calculator. Also you'll get 9, straight away 9. But we are not interested in value. We are interested in sign. This is positive. Whenever the second derivative is positive, that means it is opening up. That part of the curve is opening up. That means the point we just had, x equal to 2, is a minimum. So we'll write, since the graph opens up at x equal to 2, it is a minimum point. The nature of this point is minimum. Let's see the next part. The function g is defined by this, and if we compare it with the original function, we can say that k is equal to minus 1 in this case, right? It's minus 1 here, minus 1. All right. Determine, making your reasoning clear whether g is an increasing function, a decreasing function, or neither. What is an increasing function? Any function that goes up, and up, right? And anything that goes down is called decreasing function. And neither means it goes up and down both. Here they have given a condition that x is always positive, greater than 0, right? So in the case if the function is always increasing, ever increasing function, it will be having a positive first derivative. If it is a decreasing function, it will always have a negative decreasing function. So what was the first derivative of this? Let's look at that once more. First derivative was minus 3k, 3x minus k, okay, minus 3k, 3x minus k to the power minus 2 plus 3, right? So now k in this case is minus 1, so let's put that here, minus 1, 3x minus 1 square plus 3. So it becomes positive 3, 3x plus 1 square plus 3. This is dy over dx at x equal, no, not x equal to, k equal to negative 1, correct? Now, we can see here 3 is a positive, x is positive, they have given already. So that means 3x will be a positive, plus 1 is positive, a square will make this whole bracket positive, and 3 is already positive. There is no chance that we can get a negative dy over dx in this whole case. That means we have this case. The function is increasing function because dy over dx is greater than 0 all the times.